Congruence is indicated by the following symbol, an equal sign with a tilde or tilde. You can pronounce it either way above it, but that's the congruent symbol. And congruent simply means equal in all respects. Okay, so if two things are congruent, that means everything about them is congruent. Okay, so when you're looking for triangle congruence based on given figures, if you look at these two triangles and you look to see are all of their corresponding pieces congruent to each other. In the triangle on the left here, we have angle C is 29. On the right, angle D is the same measure. In the left, we have angle A is 54. Angle E is the same measure. Angle B is 95. Angle F is the exact same measure. So we see here that all of these corresponding angles are congruent to each other or equal. And let's test the sides. So the measure of length AC is 8. ED is the same length, so those are equal. FE is 4, so is BA. And finally CB is 6, so is DF. And so all of these pieces match up and are congruent. So if you know that all the corresponding pieces are congruent to each other, we can make the statement that these two triangles are congruent. And we'll indicate that with a congruent statement. When you write a congruent statement for a triangle, you'll start with one of your triangles, and you can pick any arbitrary order for your vertices when you write the name of your triangle. So label triangle ABC, and then identify that it's congruent to. The right side, or the remaining part of this congruent statement, though, isn't arbitrary. It has to match up or align the corresponding pieces. So when we look at A, if we started with A as our first letter in the congruent statement here, we have to start with its corresponding or equal value, which is E. In the second letter, we have B, which has a 3 tick mark. So on our second part of our congruent statement, we find the angle with 3 tick marks, which is F. And then finally, our last letter is C, has the 1 tick mark. It corresponds to the angle D with 1 tick mark. So these would be your congruent statement. Okay. Now, you can identify congruence of triangles either by finding the pieces that match up or by actually being given the statement itself. So if you start with a given statement, the way that you can identify what the corresponding pieces that are equal to each other is to base it strictly on the orientation of the statements. So if you wanted to find what are the different relationships given this congruent statement, well, we could say that side JK, that distance, is equal to JK are the first and second letter, so we take the first and second letter MN. KL is the second and third letter, so we know that distance KL is equal to the second and third letter NO. And finally, LJ is the first and last letter, so it's going to equal OM. So those would be your distances. We could also find the equality of their angles. So again, measure of angle J. J is the first letter, so it corresponds to angle M. Measure of angle K, it corresponds to the measure of angle N, the second letter. And finally, measure of angle L corresponds to and is equal to measure of angle O, the last letter. Okay, now, when you're identifying these, you could also identify the congruence of their elements, not just the equality of their measures. Okay, but regardless of that, if you have your measures here, the reason, their justification for this is definition of congruence. Right. If you have a given statement and you want to identify corresponding pieces that are equal, you would use definition of congruence. And you can do the same thing with their physical elements. Elements aren't equal, though. Their measures are. So if you're talking about the elements themselves, so segment JK and segment MN, those corresponding elements, now you have to talk about congruence. Okay, and so KL, segment KL and segment NO, would be congruent to each other, and finally segment LJ and segment OM would be congruent. Same with the angles. If you don't show their measures are equal, you could also show that the physical angles themselves are congruent. So angle J, angle K, and angle L could be said to be congruent to angles M, N, and O. Once again, you would justify these statements or any one of these statements by using definition of congruence. Right, so you can base triangle congruence off of a statement or off of the labeling of information on the figure itself. Regardless of that, once you know that two things are congruent in terms of the triangles, then you can tell all of these corresponding pieces are congruent as well. So we know the following relationship holds true for congruent triangles. Corresponding parts of congruent triangles are congruent. Okay, so this is a statement that is true. We can see it based on these statements here. Okay, but this extends even further. It extends to all corresponding measures of a triangle. So if two triangles are congruent, then that means their perimeters are congruent. Their areas are the same. Again, congruence means equal in all respects. Everything about them is the same. Okay, and so this corresponding parts of congruent triangles are congruent. Can be abbreviated using just the first letters. CPCTC is the acronym that's used to demonstrate that. Okay, so in each of these cases, writing all of these statements based on this one congruent statement, we could also have justified it as CPCTC. Same with this set. CPCTC can also be used to justify any corresponding parts of congruent triangles are also going to be congruent.